Today we're diving into some exciting developments in the world of artificial intelligence. Remember Llama 2, the impressive language model that came oh so close to GPT 3.5? Well, Meta has done it once again. Say hello to codellama, the groundbreaking innovation that's finally closing the coding gap to GPT 3.5. This is a major leap forward in open source foundation models, and we're here to break down all the juicy details. Imagine having a language model that's almost on par with GPT 3.5 in most tasks, except for one vital area: coding. Coding is like the heart and soul of a language model's capabilities. It's the magic behind strong reasoning engines and those powerful AI agents we're all amazed by, like Voyager. Enter codellama, the ultimate solution that bridges the coding gap to GPT 3.5. It's been fine-tuned from Llama 2 base models and comes in 3 flavors: vanilla, instruct, and Python, with model sizes 7 billion, 13 billion, and 34 billion parameters. Even the smallest model can flex its muscles on a local setup with a decent GPU. Now, let's talk numbers. On the human eval benchmark, codellama Python is scoring a remarkable 53.7, leaving GPT 3.5 in the dust at 48.1. But wait, there's more. While it's trailing behind the impressive GPT-4, which hits a mind-blowing 67.0, it's still a giant leap forward. On the MBPP test, codellama Python boasts a score of 56.2, outshining GPT 3.5 at 52.2. Codellama proves its mettle by outperforming other coding models like Palm Coder, Codex, that GitHub Copilot model you probably heard about, and even other open source models like StarCoder. So how do they do it? Codellama has been trained with a unique infilling objective to support code generation within a given context. Think of it like the model is completing a puzzle. It takes in a prefix and suffix, or vice versa, and then predicts the missing middle part. The model's autoregressive, but with some nifty marker tokens that keep things in line. The data for this was generated by randomly splitting the code corpus. Another set of synthetic data comes from self-instruct. Start with a whopping 60,000 coding interview questions, generate unit tests for added oomph, produce not 1, not 5, but 10 solutions, put these solutions through Python interpreter, and weed out the bad ones. Only the cream of the crop makes the cut. Codellama doesn't stop at the basics. It starts with a context of 4,000 and then fine-tunes with a context of 16,000 to keep things efficient. And with some clever positional embedding tricks, it can even maintain consistency over even longer context. Now, here's a tidbit you might be curious about. The instruction fine-tuning data is proprietary and won't be released. But hey, sometimes secrets are what make the magic happen. Just last week, ArsTechnica dropped a bombshell. They reported that the New York Times might be gearing up to sue OpenAI. This lawsuit could potentially lead OpenAI to wipe ChatGPT and start from scratch. But wait, it gets even more intense. If this legal battle goes south for OpenAI, they could be looking at fines of up to $150,000 for each piece of infringing content. That's some serious cash, even for an organization as financially backed as OpenAI. Now, here's where it gets tricky. Gary Marcus says large language models like ChatGPT aren't your typical databases where you can just delete individual pieces of information. No, it's a lot more intricate than that. If any content is removed from the model, it's not as simple as hitting the delete button. The entire model might need to be retrained from scratch, which can come with a hefty price tag.
But it's just that so many people want more GPUs, right? And if you go to like Bay Area companies, right? Like you talk to like all these Bay Area companies, Inflection and Meta and all these and Go and OpenAI and everybody's bragging about how many GPUs they have, and it's really cute. Like, and it's like, and it makes sense, right? Like researchers want GPUs to run their experiments, and so it's funny.
Yeah.
You know, I mean, we've seen, sort of. I like to joke like transformers are the most like capitalist thing that's ever been invented because you just throw more money at it and it gets better. Like log linear, like scaling is like perfect, right? You look at like these scaling laws, it's like, yeah, it actually just keeps getting better.